Jai Hind to all of you. I am Dr. Ritish Kumar, Assistant Professor in Department of Electronics Communication Engineering, Akgec Engineering College, Ghaziabad. Today, I am going to discuss the topic of pre-emphasis and de-emphasis. So, pre-emphasis and de-emphasis. This is the university syllabus divided in 5 units, where the pre-emphasis and de-emphasis lies in unit number 3. You can see pre-emphasis and de-emphasis. This is an important process to have the improved signal to noise ratio at the at the receiver side. So we need to do the pre-emphasis at the transmitter side, and to nullify the effect of pre-emphasis we have to do the de-emphasis process at the receiver side. So here you can clearly see here the first unit is related to the AM, and second unit related to the angle modulation, while the third unit is related to the random process and random variable, and the fourth unit is related to the pulse code modulation system, and the fifth unit is a digital modulation technique. So these are the all 5 units. So here in this lecture we will discuss the pre-emphasis and de-emphasis process, right. These are the recommended books. The first one is a Simon Haken. I will recommend the Simon Haken communication system, John and Wiley and Sons, and Tom and Sealing. The title of the book is Principles of Communication System. These two books are very good books, although all the books are very good, but I will prefer these two books. So let's begin the topic of pre-emphasis and de-emphasis. So as we know that what is the use of signal to noise ratio, SNR. Our aim is to improve the SNR. Why? Because SNR is nothing but the ratio of signal power to the noise power, and signal power you can write signal SI upon Ni, or generally we can say S upon N. So what should be our aim? Our aim should have the high signal strength in the main message signal, while the noise should be as low as possible. If you combine these two statements, our SNR should be as high as possible, right. So why we need to do the pre-emphasis and de-emphasis process? So to improve the SNR we need to do the pre-emphasis process at the transmitter side, and the de-emphasis process always be done at the receiver side to nullify the effect of pre-emphasis. So let's begin the analysis of pre-emphasis process. What should be the circuitry of pre-emphasis? What should it done at the transmitter side, right? So let's begin with the pre-emphasis process, right? Pre-emphasis process. Right. So as we know, the power spectral density of audio signal like you can generally have right? This is the frequency PSD of audio signal, right? And the as we can say, the PSD for noise should be like, as we generally say, as we know that, as if you increase the frequency, then you will get high noise in the system or in the circuitry. So at low frequency you will have the low noise, but at the high frequency you will have the high high noise. So it looks like generally, right, at low frequency is, if I treat this is low frequency range, if you move from if you move in this direction, then you will have the high frequency range. If you increase the frequency, then you will have the high noise power or high noise power. So you can see here, uh, here the this is the signal power strength, as I can say, or this is noise power strength, as I can say, right? So at low frequency range, this is the signal power, this is high signal value, signal strength, while at the low frequency the noise power is very low. So if I treat a certain threshold level, this is the, in both cases, certain threshold level, this is a if I say this is a f frequency, this is a threshold level. Below f, this is known as low frequency range, and this after the f, this one is high frequency range, right? So below the f, you can see the signal strength. Below the f, the signal strength is more, while the noise strength less, low. Noise strength is low. So we can say below the f, the SNR is high, while above the s, SNR is low, right? So below the f, SNR high, while above f, signal strength decreasing, noise power increasing, SNR is getting poor. So here we can see that at low frequency range, the reconstruction of signal at the receiver side is efficient, while in the case of above f or high frequency range, the SQ, the SNR, signal to noise ratio, is getting worse, and that's why the reproduction of the signal at the receiver side is very difficult, or is not very much efficient. So to improve the SNR at the higher frequency range, we have to do the pre-emphasis process at the transmitter side, right? So how it can achieve, how we can achieve the improved SNR after above the frequency f, right? So we will learn okay, pre-emphasis. What should be the circuitry circuitry we can apply here, how it looks like. So suppose pre-emphasis circuit, a system, we have some kind of system. Here we have to apply the signal power, right? This is signal power, right? As we know that this is one frequency, as we know that at certain frequency f, up to this one there is no problem, because below the f the S and R high, above the S and R low. So we need to increase the signal strength. So we have the option, either suppose S and R is signal power to the, no sir, I have the option, either you can increase the signal strength or decrease the noise power. Here we are doing the process of increasing the signal strength here. So at last we will get the high signal to noise ratio at the transmitter side, right? At the improve the SNR, right? So so here what you will do, this is your main signal, and up to point f there is no problem. So right, afterward you have to increase the signal strength above the f. So I am representing with the help of arrow. So this you need to increase the signal strength, right? Right. So you can clearly see here, this is linearly increasing the signal strength. As you can see, the strength of arrow increasing linearly. So what should be the system looks like? So up to f there is no problem. So you need to take the system response like a constant by nature, and after or above f you need to increase the signal strength. That's why you have to increase the system response linearly, suppose 20 dB per decade, right? This should be the system response you need to have, and this system response looks like if you this is the positive frequency. If you make it like this, negative frequency f, right? So if you pass this signal through this system which has the frequency response like this, then you will get the signal power like in this way. So above the f you will get high signal power here, right? So this is the process to increase the signal strength at the transmitter side. So this is nothing but it high pass filter, and you can also say lead compensator. So lead compensator circuit, you can make it the circuit of the system. So this is the lead compensator. This is nothing but high pass filter. So this is the circuit to have the pre-emphasis process. If you pass this signal from this system, you will get the signal strength at the transmitter side, right? So this process you have to do the at the transmitter side. Now what should we do the at the receiver side? So to nullify the effect of pre-emphasis process, you have to do the de-emphasis process at the receiver side. As we can see, both are complementary by nature, but what you are doing at the transmitter side, just do the opposite operation at the receiver side, you will get the de-emphasis process, right? So in the de-emphasis process, you have to decrease the de-emphasis circuit, you have to decrease the signal strength as you if you this is the signal after passing the high pass filter. So at last you need to get the original signal, right? So this is original signal. So this is the original signal after passing the de-emphasis process. So at certain frequency, after a certain frequency, you have to decrease the signal strength. So you can see here, you need to do the linearly decreasing at the frequency above the certain frequency f, right? So what should be the system looks like, the response of the system looks like. So at certain frequency there should not be any change in the system, while at certain frequency f, after a certain frequency f, you have to decrease the signal strength. That's why the system response should be linearly decreasing. So this is minus 20 dB per decade, right? So if you make it for the negative frequency range, it looks like this way. So this system, it looks like low pass filter, or we can say lag compensator. Just do the opposite whatever you are doing at the transmitter side, right? So generally it does the effect of, it does the neutralize effect of the pre-emphasis process. So the circuit for de-emphasis process, simple low pass filter, right? So if you pass the signal from this system, you will get the response like this. So at last we can say that you are increasing the signal strength with the help of pre-emphasis process. That's why you will have the improved SNR. That's why this is our aim to have the improved SNR, so that we can reproduce or reconstruct the signal at the receiver side properly. So this is the this is all about the pre-emphasis process and de-emphasis process. At last I will conclude the statement that pre-emphasis process always be done at the transmitter side to improve the SNR, while the de-emphasis process always be done at the receiver side to nullify the effect of pre-emphasis process. I think these all are clear to all of you. Thank you.